Hey guys, what's up? This is Mainak from Civil Center, and I'm back with another video on this Tekla Structural Designer. So I had done the earlier part, which I have the link I have given in the description. I had done a live session on how to make the beam column plan of this. So basically, to give a brief overview, this is a building, existing building, and we are just adding some components to it. So now you can watch out the previous video to know about that. But here we'll pretty much cover all these steps in the Tekla Structural Designer, and the steps before that we had done in the previous video. That is how to make the beam column plan out of the and the DXF file out of the architectural plan which we had received. So you can check out that in the description. So now let's get started with this. So first of all, we'll make our construction levels here. I'll just insert a base level. Let's say I'll give minus 1.2 meters for my base level, and I'm just taking this. Now this I will treat as my plinth level here, and this is my plinth level. So basically this is a B plus G plus 4 building. So this is my plinth level for my or my basement floor level, and I will insert a floor above it, and this height will be 6 feet, and if you convert 6 feet into meters, it will be 1.83 meter. Simply divide 6 by 3.28, you will get 1.83. Now the slab thickness I'm giving as 100 for all, and this I'm doing this SSL in a structural slab level. So this I'm doing. So this is my basement ready, and now I'm going with another one. So this is my next level, or this is my G. So my G is 9 feet 6 inch height, and this is 9 feet 6 inch. If you divide 9.5 by 3.28, you will get 2.89 meters. So I'm doing this 2.89. So this is my G, and I have 4 more floors above it. So this is a G plus 1, G plus 2, G plus 3, G plus 4. So this is what I am getting. B plus G plus 4 building, all the floors are ready here, or all the construction levels you can say rather are ready. So now inserting this DXF file, and in the plinth level, or rather you can say the basement floor level, I'm inserting this, and I'm just opening the DXF file which we had prepared in the earlier video, and the center line I want to import, and the unit will be always in and the next, and then bilayer and all the layers. So to give a brief a brief idea about that, G plus 1 layers have already been completed of this building. So we don't have much to do in the existing portion of the building. I'll just show you that thing also, and once I import this DXF, I'll show you that part also, what we can't do here. Just a center line, I'll deselect shadow I want, and this in let's see. Before that, let's see, before I click on finish here, these are the grids now. So let's select the grids here, and change the color to black. So after that, let's import the XF, the center line. So this select the center line, shadow, and finish. So this is, I'll need to zoom it. So this is my shadow, and this is my center line. So and just to show you the briefly about the plan here, and this will do. So this is basically the plan. Now as you can see, the red portion, this red portion is the existing building, so we can't do anything inside this existing building. We have put the columns here, and when we have put the columns here, as you can see, we have put the columns outside this existing building portion. This is the existing building portion, the dotted part. So we are putting lifts, we are putting staircases, and we are also putting this rooms, which will be in addition. So G plus 1 is already constructed, so but we are going this B plus G plus 4 in the new building part, and we are going like this. So we are going like this in the new part, and we are extending the building. So that's how we are going. So I hope that's clear. Now moving back to the Tekla part, let's insert the columns. So we don't have, as you can see, we don't have much place to provide the columns. So we have very few columns here, and the sizes will probably go a little bit more. The sizes of the columns and beams will go a little bit more. So we are prepared for that, because we don't have much space to provide the columns. But let's see how much size it goes, and I've already calculated the loads and all for the AAC block, so it's okay. So we'll give the sizes here, and for these columns, I'm hoping this orientation will like this. So I'm giving the column sizes here. Let's say I'm just editing the column size. Depth will be left depth. Now let me give this as a depth as 500 and 250 to start with, and okay. and then this I'm doing this Fe550 steel which I will be using, and after that I'll just turn off the automatic alignment and then save this. This I'll do C250 cross 500. This is the first column which I've created here, and this will how my column will look like. And here also I'm placing one column. Here and another one here. So like this I'm placing the columns here. So now let's make a different orientation for it. So I'll go this with 250 into 250. For this I'll go with 250 into, or rather I'll go your 350 into 250. Like this I can go and click on OK, and then click on the save C350 cross 250. This I'm going to use for this lift and also the staircase portion. Control Y, okay. So I'm going to select this column and I'm going to change this 350 into 250 like this. So I think it can go higher also. So let me give a higher size to it. This one. I'll just give this as your all this. I'll just give as, instead of 350 into 250, I'll give this as 450 into 250. This is the column size which I'll give. Like this we can give the column sizes, and let's add the beams now. You can see very few columns we are having. Let's see what the sizes will go. Now adding the beams, let's give the beam size of here 250 into 250 into 350. I'm giving initial beam size, and then Fe 550 which will take, and after taking Fe 550, and then I'm going to save this as B 250 cross 350. Click on OK. So now we'll just apply all the beams carefully. So this beam will go all through, and obviously here in the plinth level there won't be any beams here, because it will go, we'll have a beam upwards here. So basement level there won't be any beams. So in the basement level there will be a beam like this, it will be coming. But first let's make this beam. It will be a beam here in the basement level, and there will be a beam here like this, and here we'll have a beam. Here also, let's see if I've given a column or not in this place. Okay, yeah, we have given a column, no problem with that. So here also we'll need to give a beam here. So like this we have given the beams here, and like this we can join this beam obviously, and we'll have a secondary beam here at the basement level if we require this, or if we don't require this, we won't give that particular beam. So we'll have a projection here in the basement level. We don't need this. in the actual building we have a projection here. So we'll have this, and we'll have a this as well, hole, and here we'll have a secondary beam here. And here also let's have a secondary beam. So like this, and make the support condition, does double click on it, releases, and end one is bottom one, end two is top one, always bottom to top, left to right. The concept, I hope you know that. If not, you can comment below, I can make a separate video on that. So end one will be pinned, no column here, and end two will be fixed because there is a column there. Simple concept. Now this one is both pinned because there is no column here anyway, both will be pinned. And then okay, we can continue this. And after this, this is how this looks like. This is the base, this is basement floor, you can say. This is the basement floor. This is how the basement floor looks like. So there is a building in between this portion. We are making a particular column in the building. By breaking the slab, we'll make one column so that we have at least some columns. So we are breaking the building and making one column, but all these remaining columns we are making in the new portion of the building. So this is in the back side of the building, we are making the columns, and in the front side we are giving a lift, we are giving a staircase, and let's see, like we can also put two more columns here also. We'll see that if required, then we'll put two more columns. If the sizes are less by putting these two columns here, we'll just do that also. But let's now see whether this is possible or not. So the basement floor is ready here. So now we'll just go to the next level, and let's see. We'll just what we'll do, we'll just copy this to the next level, and then we'll work on the remaining part. Next level, it's copied. My ground floor, you can say the floor level, and go to construction levels and make this unique quickly, and click on OK. So once this is made unique, I'm just going to jump on to the ground floor level and make the changes. So here, this is the my ground floor level. This is also going to remain the same anyway, because here we won't have any beams here. Here actually there is a projection here, so we won't have any beams here as well. It will remain the same. So my ground floor will remain the same as this. Now I quickly jump on to the ground floor roof slab. So ground floor roof slab, I hope we'll have some changes in that. So we'll go to construction levels, and I'll go to my ground floor roof slab. So I'll just copy this to 1 and click on OK. And I'll quickly go to the construction levels and then make them act as unique. So I'll quickly jump on to my ground floor slab level, roof slab level, and here I'll work on that. So here there won't be any beam here as usual, but because there is a G+1 existing building here, but we can have a beam here because in the ground floor roof level, because this is basically the particular projection which we are having here, it is at a 9 feet height. So we are already 6 feet above in the basement level, and above 9 feet 6 inch above, so we can have this particular beam here. So we'll have this, select this beam, and we'll select the beam sizes, and we'll go forward with this beam. Double click here, and here what we are having, and just fix the releases here. Now this is left to right. Left one is end one, so it is fully fixed. End two is right one, it is pinned because there is no column here. So like this we are having here. So this is what we are having in the ground floor slab. Now if you want, you can put the slabs also. I haven't yet put the secondary beams here. So let's put some secondary beams also here, because basically we need this. So for putting the secondary beams, I'm just importing the DXF again, and don't need the center line anyway because we have already unit in mm. Then click on finish. Then you need to zoom this. This is a bit annoying. Okay. So I'm just selecting the beams here, and the sizes. Obviously, I have the size here, and here I'm just having to create some beam. I can create some beam in secondary beams here, and like this I can create some secondary beams. So if you want to go work on the exact actual conditions, what we need to do is we need to make the secondary beams first, and after that we can work around with the primary beams actually. So I'm just need to delete this beam, and after that I'll make the secondary beams, and this beam also I think we need to delete this, and after that let us try if there is any. So I can use this, and I can use this also, and I can use this also. It's an error. Let me join this because this is secondary beams are covered, I guess. Now secondary beams are covered. While the secondary beams are covered, we can now work on that. Now let's define the support conditions. Click on escape, and here I think both are pinned. Just go to the releases, make this pinned first. Here also both are pinned. Here do you have a column? Here no, both are pinned. Here also don't have a column here. Here also both are pinned. Here I think we've done that. Yeah, we've done that already. Here this one. This one we don't have a column here, so okay. And this one last but not the least. Definitely don't feel okay. When this is done, just click on the beams and left one is fixed because they have column. Right one is pinned. Okay, we are good with this. So let's check the validation. So validation is okay here. We don't have any problem in the validation, and this is the ground floor slab which we have created along with the secondary beams which we all want here, the secondary beams. And after that you can just put the slab. I'll put in the slabs for the self weight. Actually I don't want to design the slabs here because it anyway doesn't give any economical results here. So this lift portion I'm leaving this vacant, this staircase portion I'm leaving this vacant. So you can check out, build it again, check out in the 3D model. Yeah, so this is the model. As you can see, now you have got an idea more about the existing building. The existing building is in this part, and G+1 is already constructed, and as you can see, basically this this G+1 is constructed. So this ground floor will start from here. This G is around here somewhere, and one is around here somewhere. So we are constructing this slab, and as you can see, this is it. Now we'll insert one more floor above it. I think that this will be the same because the slabs and all will be the same in that in this floor as well. We cannot give that this beam in that portion as well. G plus 1. So basically, if this is building height is 10 and 10 feet, 20 feet, we are also going here 6 feet plus 20 feet. So yeah, I think we can give this beam in the next portion as well. This particular beam in the next portion. So let's just duplicate it first. We will be working in the structure 3. So we'll be working in the structure 3 now. Now let's go to construction levels, and in the structure 3 make this as 2. Click on OK, and after that quickly go to this and make this unique. A lot of times we forget to make this unique, so make sure. So this is my basically this is the ground floor, basement, ground floor, roof, G plus 1 done. Now this in here we can give a beam here like this. So while we can, let's give, because it's very important to give a beam. So it's such a long span. I don't think it will pass in 350. So let me give a higher span anyway. 250 cross. Can we give this? Okay, let's give this 400. Just give this 400 and check in the structure 3D. Yeah, I think we need to give this 300 as well because this span is also large. So yeah, we might have to give this 300, and this beam also we might have to give 300. So we'll see. We might have to increase this as well because this span is also huge. So I think we might have to give 350 as well because of this particular span here. So I'm just going to give this. I'm just going to change this column right away because I know. So what is the use of testing this? So I'm just going to see here. I'm just going to make this as 350 because I think minimum this amount will be required. And okay, and I'm going to make this beam also because it doesn't have any support anyway. So this beam 215 to 500, and this one also, this beam also 215 350. I don't think this beam will. Okay, see, take this. Okay, this 2 has a similar kind of loading. Actually this has more loading because, so I'm just going to go with 215 to 500 for this as well. So because I know this, so bottom one also, this one also, I'm going to go this for this also 215 to 500. So that will help me better because this once we have more accurate results we have, the more it will help me to design the building. Okay, so enough set. Now this is the G plus 1 which is set now, and here and in this particular level we are already above what we want here. So in the next levels we can start working. So as you can see, this is the building plan which will be constructed above the existing building portion also. So we need to make the secondary beams for this portion also. So let's do this in the structure 3 while we can. So we'll just import the DXF file here of the shadow. Import DXF. Just import the shadows here. And center line, we don't need shadow, we need that and then finish, and then zoom it, and then after zooming it we'll just make all these this internal beams here. This beam will just merge with this because this will be the case here. We'll merge this beam with this, and all the remaining beams we'll just make, and hope we can make all the secondary beams. We have some points for making this. So okay, let's go, and let's take the size of 215 to 350, and we'll start making these. And so this one, let's go for an entire beam here like this. If this is required like this, you can go for an entire beam here from here to here. And if you want, we can just delete a particular beam and start with this. So let's delete this beam. What was the size? Let's check the size what we had given for this beam. Normal size we had given, but it will take more size actually. Beam and then 250 into 400. Okay, 400, let's go, because this will go from here to here. And let's switch back to 350 for the remaining ones. This will go from here to here, and from okay, there are some parts here. Just close this, and beam 351. So making the secondary beams, you often have to delete some beams, so that's the case. So as you can see, we have to do some work in this. It's not that easy for making a structural drawing, so we can respect structural engineers for that. Okay. This is better. This one. This one will do here. This one will do here. Now let's continue this actually, because this is can't be hanging here. So let's get finished with this releases, checking releases or fixed pinned. So all these basically are this is pinned. I'm just checking the releases here. Pinned. Okay, this releases are here. Pinned. Okay, so we'll do this, change this stuff. Pinned. Make sure you don't miss anything. Double check also. This one is done. Let's move to this grid. This is also this is done actually. This is also pinned. Everything is pinned here. Just do this. Pinned. Moving on to the verticals first. and then going for the horizontals. You can develop your own strategy. Pinned, pinned, okay, here, pinned, pinned, here also. We'll just do this as your pinned, pinned, and here also releases. Okay, this is already done. This, just check, double click, releases. Okay, this one, I'm just double checking whether everything is okay because I don't want any error in the design. And okay, releases, yeah, done. So here also, as you can see, we have a column here and a column here, so this both will be fixed, so we don't have to interrupt here. Okay, good boy. So here also, now remaining all these are pinned. This one, just do this as pinned, pinned. Here this one releases, this one will be pinned, this one will be pinned. Okay, this one, what is this one? Why this is in small parts here? Is this a column here? So this is not a column here, so I don't want this as small parts here. Can I extend this? Just click on, or rather delete this, because, and then make a beam here. Take this beam and from here to here and select this, releases, pinned, pinned. Okay, this one will also be your pinned, already done. This one, okay, this one, this one, I think this one is done. This one is column to column, so no, don't worry about this. Okay, still we have missed one. This one we have missed. Just delete this and go to beams and take a size. I think this will be very basic size here because I don't want to 250, 250. Now I have to delete one of this, so these are the things that you need to take care of actually. As you can see, working on an actual project is not that easy. Like you'll have everything done here. This is a column to column. Let me delete this. Now just check the support point. This is a column to column. So once this is done, just take the slab on beams and just put the slabs here. I'm just going to take the slabs for the self weight. I don't want it for any other purpose. So the slabs have been given, and after that I'm just checking the structure 3D here, and after this is done, we'll just have this structure done, and this will be basically copied to all other levels because this will be the same. So we'll just go to construction levels and just copy this 3, 3, and then 3. Okay, so once this is copied, go to construction levels and make this back as unique. So now it's a good practice to, when the model is done, good practice to save the model file, save as, and here you can just save the model, full building model without loads. So full building model without loads I have made. Now let's apply some loads here. Very easy in applying the load, so will not take much time. So they according to base, and this is the basically the the level of basement. So we'll apply simple loads here. AC block load, we have loads we have calculated. How to calculate that load, I'll make a separate video for how to calculate the load of AC blocks. So we'll make a separate video on that. Now let's just apply the loads here. And here I'm just going for the dead load first, and going to the loads. Let's quickly apply the loads. Basically very easy process. So here for the AC block, for 10-inch wall, 3.8, 5-inch wall, we have your 1.9, 3.8 and 1.9. Let's go. Load here is 3.8. I'm just going to apply this here. Now let's apply the 3.8. Here there won't be any wall actually, because we won't need any wall, but let's apply. In future is hope if there is any wall, won't do any harm anyway. So this load is applied, dead load 3.8. Now the next floor, going to the next floor, structure 1, and this is a height of 9 feet 6 inch. So 10-inch wall 6 and 5-inch wall 3. So 6 and 3 will apply. So going to load and click on the dead load, full UDL, and taking the 6 kilonewton here and applying it in the external walls. I think all are the external walls here. There are no internal walls in this. Here we have done this, and in this level we hadn't created any internal beams in this portion. So we are going like this. So this is our G, and the next level we'll just go here. So dead load, same 6 and 3, 6. Let's go 6 here, 6 here, 6, 6, 6, 6. Let's check. You can like if you have any confusion of this, you can check this. Just click on escape and click on this 2D 3D, and after that you can check whether you have any doubts. Just 6, 6. Okay, now I'm doubt is cleared. Using the right mouse cursor button, you can just rotate the model, and then I'll just go back to the 2D anyway, and then apply my 3. Here this staircase portion, so I'll apply the 6. This is left. Yeah. Now it's done. Now let's quickly apply the imposed load. Imposed load, this is a level load, and we need to apply the 4 kilonewton load for the commercial here. Loads applied, beautiful as it is. And when this particular load is applied, we can copy this to 1, 2, 3, these levels. So we can see imposed load. starting from this level, you can go to the model and then construction. Just click on escape. This is not coming, and after that just rotate the model or something, and then go to construction levels, and then we are working on this, as you can see, structure level 2, and then make this, as you can see, this is the level in which we had worked. This is the level 2 in which we had worked. So as you can see, this is the level in which it worked. So let's apply the load for the next level as well, and after that we can easily do that, because that will be the case. So let's go for the 6 and 3. Very easy. Dead load first, and then the loading, full UDL, and 6, going for the 6, 1 2 3 lift portion. That's why I'm applying the 6, and here 6, here, 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 here. I think we completed. Let's just, okay, staircase portion, 1 2 3. Now let's just see in the 3D view all the external walls are applied or not. I think they are done. Now for the 3 ones, 5-inch walls, 3. It'll also take some time making this safe, because very few columns, as I told you. It will take some time making the structure safe. Hope we can do this within 1 hour. 40 minutes into the process already, and before that we add the, okay, now the imposed loads, level load of 4 kilonewton per meter square for the commercial building. If you add the process of making the architectural plan and then the adjusting the architectural plan for the beam column, that will be entire process. So hopefully this software doesn't take much time actually, to be honest, but the earlier process, remaining process is really. So we can just complete this, make this as 3, make this as 3. Top, we can't give this. Okay, let's copy this to the, no, top we can't do. Terrace, we'll have different type of loading. Now once this is done, go to construction levels and make them as unique. Yeah. Now let's go to the terrace portion and apply the loads for the terrace. Just go to the loading here, dead load, and here what we'll do, here let's apply the loadings for the terrace portion. So for the terrace portion we'll apply the load. So let's apply here the loads here, load, and the dead load, the UDL. So I've calculated the load for the parapet wall of 1 meter for the WSC block is 2.089. Actually I'm taking this 2.1. So full UDL, and I'm just doing this as 2.1, and I'm applying it in my entire terrace portion. This will be my terrace here. Lift wall portion, I'll be having 6 for the lift and the staircase portion, because they will have the loads anyway. I think we have applied double loads here, so I'll use the UDL option for this. From here to here, and then full UDL back. This, and in this UDL portion, this is the what we have, this 3. Okay, so this is done. Now just check out the terrace portion here, and now imposed load, level load, commercial 4, done. None. Let's check this particular model construction levels. All are unique. Okay, now it's a wise thing to save all the dead load live loads as well. Control plus S. What did I do? I shouldn't have done that. Save as. Not in here. I shouldn't done that because that was without loads. Now let's building with live and dead loads. Okay. Now let's create a new file so that this error doesn't come. The next stage with all loads. So this will not create any error in the future. So model, wall panels. Not from here actually. From the which level? This is the basement. From here we can do this. Once this is done, go to the loading part, seismic load, seismic wizard, code spectra. Ignore below this one because this is where we start. This is zone 3, importance factor 1 for the residential, commercial, not normal place. And this model response spectrum analysis, RC moment resisting frames, moment frame systems, taking the dead loads and the live loads into considerations. Next, finish. This is the load combination and the operating scenario. And they click on the next here, finish here, and just clicking on some wind wizard. We don't want to consider topography, and next here basic wind speed 50, and just click on next. And this fetch distance 5 meters by default we take next, and then next, and then click on this finish. Create some load combinations out of this, generate some load combinations. Next, all limit state combinations have been selected. Next, finish. Okay, this process is fast. Now comes the main process. Now let's see. We'll have to see and check and see whether the members are pass or fail, and before you design this. So I'm just going to turn off the wind panels because that will help me in checking. Let's see whether we have the wind panels here. Turned off successfully. So now I'm just going to check the sizes of the beams here. These beams I know these beams need a higher size at least. Okay, let's give the design all. Let's see how many of them are passing. Design all static. Let's give. A few of them passed actually, so I hadn't expected that. So it's good. Okay, so let's check out from the front. Let's make the column safe first. Okay, so for making the column safe, this is actually this lift. So let's go and check out the sizes here which you are having. We can only increase this portion. Let's go 400. So this will do. Design selection static, right click and that design selection static. Okay, this is done. Next mission is this one basically. So the size here is 315 to 500. Now 400 into 500, 50. These two, let's see. Some portion as sleeve. Okay, we'll come back to this later. I think remaining beams, let's see. Yeah, this one we can just increase in one direction, a little better. 500. That this is 2. No, just taking more. Let's do this as 550. Will it do? Let's check. Oh, this is better. It's becoming better. What is the ratio? Let me see. 1.056 axial force. Okay. I think we'll need to give 650 here. Still, I think we need to go for the breadth as well. But we need to give the breadth in the opposite direction here, because this is the staircase anyway, because we need to little bit extend this. Better. 80-32. This is too much actually. I can, if I increase this 350. to 25. This will do. There is much load coming on this now. This one I think we can. This one and that one is similar. So this is 250 into 500. into 550. Will this be enough for you? No, not. This one, what can we do about this one? I think let's give it a little bit width to this. 300 into 550. 350 into 500. Still not enough. $400 into 600. $20-32. Still lot more reinforcement here. What is this size? 400 and 600. 18-25. Let's design or static. Let's check out again. What is the changes which we can achieve, which we have achieved? Okay, some columns are passing here now. This one, let's give this okay, let's just change the settings a little bit. This is 550, we'll just do this 550. 25 also, this is 550. 550. 12. 20. Or you can use 25 here as well, because this is 25 columns. FE 550. 16, will use 16 here. Here FE 550. 32. Okay. Now let's redesign this. Let's see what happens. It will get better results. So what is the size now? So this is these remaining columns: 400, 600, 600, 650. This also. Select this 2. I want this. Okay, this is pass. Let's see the reinforcement. What is the reinforcement is getting? Is it achievable? 10 of 32. This one's more. Size 700. Still it is not near enough. 800. Oh, it's done. This one also I think will go similar to this, like this. 400 into 800. Yes, this is done. So like this, all the columns have been safe. So this is going for the columns. Now this is going for the beams here. Let's go for the beams. So let's make this beams as, select this beams. All the plane beams have been selected, basement beams basically, and go to 15 to 400 and then right click in them and then design selection static. I hope this will get safe. Yeah, this is safe. Now for the next one as well, we'll just select this, but this will actually increase the self weight, which increases the size of the can increase the size of the columns. This will also 215 to 400 and then right click and then design member, design selection static. So we'll just take into that into consideration also, but later. This particular one here, I don't think 400 will be enough for this. 500. Let's give 500 and then design member static. Yeah. So let's see the steel which is used. 2 bars of 25. Okay, I'm good with this steel. Yeah, no problem. Now the next remaining things, top one. So here we have to select a little bit carefully. What do we have here? Internal beams. I don't want to select this internal beams because these are already passed. So, but can go with this. I'm just going with this all because do not deselect anything. So here, the sizes which I am giving, section. Now let's give this 250 into 500, 400, and let's check design selection static. Some beams we need to give as 500. Entire line I'll make 500 because this is 500. This also we'll just do in once. Why just beat around the bush? Section I'll just 215 to 500. Design selection static. Now let's do this as section 215 to 600. Why? Just give a proper section here. Design selection static. Obviously some beams will fail, so we need to take care of that. The beams which will fail, we need to just check and make them as pass. So we need to go into one particular level and make all these beams as pass. So we need to do that. And let's make this all these beams 600 first. So as you can see, there are some beams which we are failing, which we have to increase the size and all. So let's see, this is the column size. What is the column size here? This is 250, so we can't increase the other dimension of the beam, so we have to work around this as well, this only. So here let's go for a higher size, 650. And when you go on for the higher size, right click on this and design selection static. Let's see, still not fast actually. So we'll need to give a higher size, 750. When it's still not passing, you can check out from the idea that you need to increase the other dimension, but here right now this is not possible because this is a lift beam, so we need to make some other arrangements for it. Maybe a little bit changes in the plan, so we'll do that. Let's see, let's increase the other dimension. So now it's passing. So let's see if we can just change this particular thing and the size here. Span 1 left to right. Span 1, we'll just change this as 250 into 600. Okay, and like this we can do. So let's design all static to check. Let's see whether the increasing the self weight has affected the columns or not. Yeah, so as supposed this columns, some of the columns are failing again because the self weight has increased. So here, as you can see here, this one and this one, both this size will just make this increase the size a bit. Just make this as 450 and then design selection static. Now this is good. So like this we can proceed with making the beams safe in all the zones here. Like this you can proceed and make the beams safe. So we can also provide the foundation here. You can also go for the okay, so when this is not safe, this really needs to be safe, at least to the exterior beams. Let's make this exterior beam safe. So I think we need to give this a bit width. This will be 300 into 600. We have this 300 into 600 or 350 into 600. Let's give, we have enough space for that. What is this beam all about? $350 into 600, 350 into 600, 350 into 600. This one also, this particular beam also, this for this portion only, span, I'll rather go for the span 3, size span 3, and this particular span size 350 into 600. Okay, double click, size span 3, 350 into 600, double click, size span 3, 350 into 600. Okay, now just simply design all static. So still this particular beam is failing in some reason. Let's check this again. properly. So the third span is still failing, so let's give a little bit more size to this. Double click on this, sizes, span 3, 350 into 750, or 350 into, okay, not 750 actually, little bit more, uh, 650. Let's give this. Okay, design member static. Now it's pass. Span 3 pass comfortably. Now this, for this beam, what we are worried about is your left to right. Okay, span 1. So this span 1 we can change here. $315 to $650 we have. Now let's just check this. Okay, this is working, but the reinforcement is too much actually, but okay, but this is size more, so we'll just double click, size span 1, 315 to 650. Size is 315 to 650. Now let's see design all static. Okay, still this is not working for some. So let's go design member static. Why this is failing? Again, let's size span 1, 315 to 700 do you need? Let's check this. Okay, this is good. Span 1. Design all static. So when you do this, it's kind of failing after that, but I think it's some kind of glitch, because initially it was showing that it was passing. So section inadequate for torsion. So if this section is inadequate for torsion, what we can do is we can double click on this, go to the sizes, and span 1, give a new size 400. Now size this 400, size 400. So what is this? Why is this failing? Let's check. Stirrups. Okay, with this I am not concerned with the stirrups, because it will pass anyway. Go design all static. Finally, we have accomplished our mission. This is passed. So what is this causing problem anyway? This is actually, if you look, this is span 2. So right click on this. I just don't want to store the slab items. Just turn it off. Double click on this. Size span 1. Little bit more size you want. Okay. Now the remaining things which are definitely failing, like we'll go on a particular level and check this beam. What is the size which I'm giving here? 215 to 600. Oh no, 315 to 600. Let's give, and let's give this for all the beams here. Now the remaining one, what is the size? This one is 215 to 600, and it's failing, right? So let me just give. I don't think this portion is failing, so let me just fix the span 2 and span 3 of this particular thing. So for the span 2 and span 3, I'm just going to click on here and change. Double click, size span 2. I'm going to do this as your 350 into 600. Okay, double click, size. Okay, span 3, I should have done it once. 350 into 600. I'm going to click on this as well, top one. This one also I'm going to give this as span 2. Done. The remaining one, okay. Now let's see, this small beam shouldn't have failed actually, this one. So what is this? This one also, let's check. This one also I'll do the same. Now this one, what is this size? 215 to 500. This shouldn't have failed. I think it only needs a bit to breadth. 300 to 500 to 2 for this. Let's see, design all static. Got some success. Okay, this one needs more actually. Then let's focus on this one first, and then we'll do the remaining ones. I think. What is this one size? 315 to 600 doesn't do this. 400 into 600. How about this? I should have the columns of 400 as well. I think I have this. The size is 250 into 600. Okay, so this will do, and this column is already okay. 400 into 600. Let's do, and this one also. On this review option, have this copy properties. Okay, and attribute in the section characteristic beam. Okay, this is complicated. Look, let's not use the normal procedure. Skip to cancel. Now I need to do this design. What I was doing, design again, this to make the window. So actually this is past, this set size of this 400 into 600, this is past, so I'll apply this to this as well. So I hope this will pass now. Now this size, what is this size? 250 into 600, this size. Into 600, let's do this. Now about this section 3, just need to modify the section 3. I think section 3 needs more size, span 3 to 350 into 400. I think this needs 400, but the question is whether we have columns of 400 or not. No, we don't have. This column size is 250 into 600. We can't give 350 anyway. So these column sizes, actually we need to give this 350. We have already given 600. I don't want to go more than 600. Okay, let's just go to this sizes, spans 650. Let's check. Still I think we need to give more. $400 into 600 we need to give, I think. Now it's done. So we need to do this column size also. We need to change this column size also. 400 into this will be 400. Just do this, does not create any confusion in the future. That will do. Yeah, I think that will do. Design all that one, this one also small. This, what is the size? 300 to 500. I think it needs more. What do you want to give? 400 to 600 do you want to give? Okay, now nothing else. Okay, we'll see. Design all static. Now almost we are done here. This one, what happened? Okay, this is failed by small, very small content. This is 1.01, so we can ignore that. This is 1.02. Okay, let's ignore that as well. This is 1.029. We'll ignore this as well. So this is the beam arrangement. As you can see, this is almost pass. So here we'll just save this file as with all loads, and save this as software hanged a little bit, crashed actually. Just wait for some time. So let's save this finally. Save as building safe. Now I'm going to create a new save as folder with foundation. Click on save. Go to foundations. Then foundation settings, let's do first. This reinforcement FE550, okay. We're good here, I think. Now click on OK, pad base column. Pad base is created. And then design pad bases. Okay, pad bases are safe. So the foundations are done. So the complete building design has been done. Now it's time to generate the drawings. So we'll see how to generate the drawings in the upcoming videos, but I hope in this video, 1 hour 30 minutes almost, the video is 1.5 hour video, you have seen what is the process of making an actual building. And in the earlier video also you must have seen how to make the beam column plan out of this. So hope you got to learn something from this video. If you have learned something, just comment nice Tekla tutorial in the comment section. That will encourage us to make more videos like this for live projects, giving you practical experience. So that's all for today, guys. See you in the upcoming videos. Bye bye. Take care.